In this section, we will discuss about the layer 3 out into the Cisco ACI. Layer 3 out is used to provide the connectivity between our servers or the devices that are connected into our ACI fabric to the outside via any routing protocol, let's say EIGRP, OSPF, or BGP, or either it can be static also. So you can see in the diagram, say we have the spine switches and the leaf switches, and here you can see we have the layer 3 out. So the switch where we connect the outside devices, let's say this is the router, we call it the border leaf. So this is our border leaf, okay, wherein we connected some device which connects to the outside world. You can see here we have the intranet or internal services into our data center maybe, and here we have the internet connectivity. Maybe this is the ISP, right? So basically the layer 3 out is that we connects our ACI fabric to the outside world. Now let's move to the next slide. So we have the function of layer 3 out. So the basic layer 3 out functions are, first of all, you can see here we mention here that we learn the external routes, right? So we connect the outside device to the ACI fabric, and we are going to learn all those external routes via the L3 out. So this is the one of the functions of L3 out. So it can be done via any routing protocol, as we discussed a few minutes back, like EIGRP we can use, and we can use OSPF or BGP. Also, we can use the static routing. The second function of L3 out is uh, to distribute the external routes to the leaf switches. So all the external routes that we'll learn from the outside world, we are going to distribute that into our ACI fabric, or in other words, all the leaf switches in our ACI fabric, they are going to learn about those external routes. The third function of L3 out is to advertise the BD subnets to the external network. So all the internal subnets, which in ACI we do have the BD subnets or the bridge domain subnets. So we are going to advertise those BD subnets to the external network using this L3 out function. Okay. The last one is that there can be multiple L3 outs into the Cisco ACI. So there is one more function wherein we learn something from one L3 out, and the ACI network is working as a transit network. So it takes something from one L3 out and it passes it to the another L3 out, which is connected to the Cisco ACI. So this function is called the transit routing into the layer 3 out of Cisco ACI. So we'll discuss about this in detail in our future nuggets. So in this section, you can see here that we have a tenant called test. In the tenant, if you go to the networking here, into the networking, and then if you see here, we have the layer 3 out. So this is the path. We go to the tenant. In the tenant, you go to the networking, and then here we have the option to create the layer 3 out. So these were the four basic functions of L3 out. Now, if you talk about the layer 3 out configuration components, so we have different components. So first of all, you see we have the root of layer 3 out. So it means that in this section, there are multiple options that will be selected while configuring the layer 3 out. So first of all, we are going to select the protocol to deploy. Okay, so let's say this is our border leaf, right? And we are going to connect it to the outside world. Let's say this is some router here on the outside. So between the border leaf and the router, we need to select one routing protocol, right? Either it can be EIGRP or OSPF, it can be BGP as we discussed, or there can be static routing also if you want. So we need to select some routing protocol to deploy here. Now select a VRF to deploy the routing protocol. Now we need to define that to which VRF this particular layer 3 out or this protocol where we are deploying this it belongs to which VRF. Okay, so we need to define the VRF to which this particular layer 3 out is going to be attached. Okay, and on that we are going to run some routing protocols to this outside network. Third one is we need to select a layer 3 domain, right? If you remember the previous sections, we have the domain, right? Like we have the physical domain and VMM domain, etc. And in the domain we have the VLAN pools, correct? So we need to define the VLAN pool which are attached to the domain. So the VLANs which are part of that pool are only allowed on that particular domain, or the device that is going to attach on that particular interface, only those VLANs are allowed. So likewise in the layer 3 out we have the layer 3 out domain, wherein we need to define the range of VLANs and interfaces that we are going to use to connect to the outside device. Okay, then in the next section of the configuration components we have the node profile. So in the node profile we are going to select the leaf switches on which the routing protocol will be deployed, right? So let's say this is my border leaf, and let's say its node ID is let's say 111. So we need to select the leaf switches wherein we are going to deploy this layer 3 out. Then we need to configure the router ID for the routing protocol on each leaf. So it is not something like our legacy devices wherein let's say you do not manually configure some router ID, then it is going to pick up from the interfaces that are configured on the switches. So in legacy it automatically picks up based upon some parameters that uh, so it is going to pick up some IP address as in router ID if you are not manually configuring it. But it is not the case into Cisco ACI Layer 3 out. So you need to manually define the router ID for the routing protocol. In the note, I already mentioned. So we discussed this, and in the node profile, we can also have static routes if there are any. So we can define the static routes here. Now let's move to the next slide. The third component is the interface profile. So wherein we are going to define the parameters related to our interfaces. So you can see here the first one is to configure the leaf interfaces on which the routing protocol will be running, correct? So it can be an SVI, it can be a routed port or the sub interface. So we can choose different, the interface ID, what will be the IP address and so on. Next, also we can define a policy which are the interface level routing protocol parameters policies. For example, let's say if you need to change some hello interval of the protocol, let's say BFD, or you can also set some parameters related to your protocols. Likewise, in let's say in BGP, you can set BGP AS override or local AS replace, etc. Local AS or maybe replace AS you want to set. So we can set it using this option, interface profile. Then we have the L3 out EPG. So we have different uses of the L3 out EPG. The first one is the traffic will be classified for the contract. So we'll discuss all these parameters in detail, but I just mentioned here. So the first one is that the traffic will be classified based upon the contracts. Second one is the transit routing. Then we have the VRF route leaking. If you want to leak the routes between the VRF, so this option or will take the help from the layer 3 out EPG. And then we have the route control profiles. All these options we are going to discuss in detail in our future videos. So this was the layer 3 out EPG. Now let's see some brief about how we are going to distribute our external routes into the ACI fabric. So ACI uses the MPBGP with the VPN v4 into the ACI infra VRF. Okay, so between our fabric devices, we are going to use MPBGP VPN v4 address family. And the VRF, this we already discussed multiple times, that within the fabric we have the infra VRF, or it is also known as the overlay 1 VRF. So it is going to, we are going to use this to distribute all the external routes from the border leaf to all the other switches in our network. So most of the configuration of this MPBGP and VPN v4, everything is automated. We just need to do some basic configuration. Okay, so we need to define two things. The first one is the BGP AS number for the ACI fabric. So we need to define what will be the BGP AS number. Okay, for whole of our fabric, for the spine and the leaves. Then we need to define our spine switches as the BGP route reflectors. So our spine switches are going to act as route reflectors as our legacy. So we know how the route reflector works, and all the leaf switches, they are going to work as an route reflector clients. There is an important note. So the MPBGP is per port. So if we are having multi ports, so we need to make sure that each port has at least one route reflector. Okay. And if you go with the Cisco recommendation, so 2 route reflectors per port is recommended by Cisco. But at least there should be minimum 1 per port if you are using multi-port architecture. You can see from where we can set the BGP related parameters. You can go to the system, and from the system you need to go to the BGP route reflector. You can see here, and once you click here, you can see you can set here the autonomous system number. Here you can set the BGPS number, let's say something, and you can see here the route reflector nodes. At the bottom you can click on the plus sign, and then you can select the node ID. Let's say my border leaf ID is 123, so I will select the node 123, and also my border leaf is, let's say, node 124. So sorry, it's not the border leaf, my bad. These are the spines. Okay, you can see here these are the route reflector nodes. So it means we need to select the spine switches. So you can see here we mentioned here that we need to define two things. So BGPS number, which we defined here, and then we need to select the spine switches as route reflector. So this option is here for the route reflector nodes, and we are going to select both our spine switches. So let's say my spine switches are 123 and node 124. So I will select both the spine switches. That's it. This is the only configuration that we need to do. All the complicated configurations that are automated, and we don't need to do anything. So this was the basic configuration for the external route advertisement. So that this diagram we already discussed. Now if you see here, there is a note. Now all the leaf switches are going to receive these external routes, right, via the spine using the MPBGP. And we have the leaf switch. Basically, as we know that we have the border leaf switch, right, which is connected to the external network. So this is going to send the updates for the external network to the spines, because spines are the route reflector. Then spines are going to distribute these to all the other leaf switches, these routes, right? But as we know, in legacy also, the route reflectors are not going to change any next hop by its own, right? So when the leaf switches are going to receive, let's say I advertised one subnet 10.1.1 something, it comes to the border leaf, it is going to send it to spine, and spine is going to send it to leaf. So if we see the route on the leaves, so 10.1.1.1, its next hop will be the tap address of border leaf, because spines are not going to modify the next hop. And if you, let's say I am on some leaf, if I say show BGP session VRF overlay 1, so this is how I can check on a leaf my BGP neighborship with the spine switches, right? You can see here we have a neighborship with 65 and 66. And if you want to see what are these 65 and 66, you can run this command ACI diag FNV read pipe grep spine. So we have BGP neighborship with the spine switches. This command we already discussed multiple times. And for the BGP, you can run this command show BGP sessions VRF overlay 1. This is the infra VRF. And you will only see the BGP neighborship with the spine switches. So let's say in my environment, if I have 2 spine switches, so I will see only 2 BGP neighborships. Now let's see some brief about how the advertisement will be done for the internal subnet. So if we talk about the internal subnets, we have the BD subnet or the bridge domain subnets. So how we can advertise the bridge domain subnets to the outside world? So there are multiple ways in which we can advertise the internal subnets to outside. The very basic one is that if we go to the BD, then this is the path network, tenant, networking, and bridge domain. Into the configuration tab, if you we can configure the subnet. Okay. So, and when we configure the subnet, there is an option you can see here. It is advertised externally. So we need to click on this option, advertised externally. And secondly, there is, you can see here, the associated L3 outs. So we can click on this plus sign here, and we can associate the L3 out to which we want to advertise this particular subnet, right? So these two options we need to check to advertise our bridge domain subnet to the outside world or to the outside network. So as we discussed, we have two options. So in the BD, we need to click on the checkbox for advertised externally, that we want to advertise this particular BD subnet to outside. And also we are going to associate the BD to a particular layer 3 out, where we want to advertise this particular bridge domain. So as soon as we do these two configuration, internally ACI is going to create a route map on the border leaf switch to redistribute these BD subnet into the routing protocol of that particular L3 out. So if the BD subnet is existing on the border leaf, or if that particular BD is already deployed on the border leaf, then it will be automatically advertised, okay, using this particular automated route maps. But let's say if that particular BD is not deployed on the border leaf, then by default it is not going to be advertised because that particular BD is does not exist on the border leaf. So the solution of this problem is that we need to have a contract between the EPG of that particular BD, right? So that BD, so there will be some EPGs, right, that are associated to that BD, and then we'll be having EPG for the L3 out also. So we'll be having layer 3 out EPG. So we need to place a contract between L3 out EPG and the EPG that belongs to that particular bridge domain. As soon as this is done, then Epic is going to install that particular BD subnet on the border leaf switch. And then it will be the same process using that particular route map. That particular BD subnet is going to be advertised to outside. I put a note here that all these route maps are taken care by our fabric. We do not need to implement anything. So as we keep on saying that most of the complicated jobs that are done automatically by our fabric. So we need to have some basic configurations only to make it work. Here are some commands to verify, though you will hardly run these commands because the fabric is quite stable, and just for understanding I just put these commands here just to make you understand. So let's say this is my border leaf. On the border leaf, if I run this command, let's say show IP OSPF VRF, I have some VRF, let's say VRF1 on 10 and TN. So this is how I can check the connected route maps. And the same command I can run for EIGRP also, show IP EIGRP VRF and the VRF name. You can see here there is a direct route map. And if you run these two commands, so for OSPF and EIGRP both, same route map will be applied by our ACI fabric. Okay, so it means that you can see here, I put one note that same route map is used for EIGRP and OSPF if it is configured on the same border leaf into the same VRF. What does it mean is that, let's say you have, let's say this is my border leaf. Okay, so this is my border leaf, and to this border leaf I have let's say this is my 2 layer 3 outs. Okay, and on one side, let's say I'm running let's say here I'm running OSPF. Okay, so this is, let's say, R1, and here let's say I have R2, and here I'm running EIGRP. Okay, so I have two layer 3 out. Let's say this is layer 3 out 1, this is layer 3 out 2, and these are part of same VRF. Let's say VRF1. Now let's say I have one BD subnet, let's say 10.1.1.0/24. Okay, now Let's say I advertise this particular BD subnet into OSPF. Okay. Now problem here is that because we are using the same route map, connected route map, okay, for EIGRP and OSPF. So by default, this particular subnet will be available on both sides. So your ACI fabric is going to advertise this particular BD subnet into OSPF and into EHRP as well because of that route map setting. Okay, so this is what I mentioned here. That same route map is used for EHRP and OSPF. This will be your VRF ID. And on the border leaf, if you so when we run this command for the OSPF and the EHRP, you can see the name of the route map. And now if you open this route map, you can see here it is matching some prefix list, which is also not created by us, but by the system itself. So this prefix list is basically that we are the BD subnets that it is matching the BD subnets. Okay. And if you open this prefix list here, show IP prefix list and the name of the prefix list, you can see here the BD subnet that we are advertising. Now let's move to the next slide. So in our previous slide, we have seen the commands related to EIGRP and OSPF. So now if you want to check or if you have the BGP to the outside, so you can run this command. So show BGP process VRF and the VRF name. So if you see here, we have the route map. And if you see here, show IP BGP neighbor and the VRF name, you can see here we have a outbound route map. And in this route map, you can also see that apart from the VRF detail, you also have the name of L3Out. So it means that, see, these BGP route maps are per layer 3 out, and these are not in shared mode. So if you're using the BGP and you have two layer 3 outs on the same border leaf and say into the same VRF, so when you're advertising something into one layer 3 out, it is not going to be advertised by default into the second layer 3 out, because this is this was the case into OSPF and EIGRP. They were using the same route map for the redistribution of the BD subnets into the same VRF onto the same border leaf. So that was the condition. But in case of BGP, it is per layer 3 out. If you are advertising something into one layer 3 out into BGP, it is not going to be advertised by default into the another layer 3 out on the same border leaf into the same VRF. Rest everything is same. You can open this route map. You can have this prefix list, and then you can open the prefix list to check the BD subnet advertisement. So this was some basic idea about the layer 3 out. Now we'll start discussing into more details about the layer 3 out, because there is a lot of stuff in layer 3 out, and this was just the beginning, and it's a very vast topic. But anyways, we are going to see each and every details. So in our next section, I think I would like to discuss about how we are getting these external routes and how the MPBGP works to redistribute all those routes into the ACI fabric. So we'll start digging into that topic. So till then, keep learning and thanks for watching.